Hey guys, my name is Venkatesh, and today I'm going to talk about the Hazelcast. What is the Hazelcast, where it is fits, and why the industry is being everybody is adopting the Hazelcast, and how it is going to solve our purpose. Before proceeding with the Hazelcast, we have to understand what is the cache. Okay, so cache is something, suppose that it's a fast memory, fast access of your data. So suppose that as we know, we have primary memory, secondary memory, or you can think of it's a server. Okay, and it's a kind of server where it interact with a database or any third party libraries or third party data source which takes time to respond. Let's say 5 seconds, someone is taking 10 seconds. So what it does, our server that does is just cache it part of the same information in your local or in an application server. Okay, and then it's available for you for the easy access. Okay, let me take you another example in the board that will have a more clarity. Let's say we have a person who's trying to access, let's say, XYZ data and is tries to access the server. Okay. Server normally goes to database and fire the SQL query. Okay. And then finally, it retrieves some data, responded back, and is a respond is processed over here, and then again it's going to send back to the user. Okay, now the thing is that after let's say 5 seconds or after 10 minutes, same user has requested for the same data XYZ. So in the current scenario, it will go to the server, it will fire again an SQL, and it will go to the database, retrieve from the database, and process it and send back to you. So here we can, if the data which is going to be same, okay, we can avoid the second query because it must be already available for the fast retrieval. Think about the volume, about the Flipkart, Amazon. They are trying to access uh, the price or product of the same product. Okay, and there are the millions and billions of the user which are constantly accessing the most common resource. Okay, see the network calls that after the server it is going to hit some particular database. Think in the terms of the numbers. To minimize this, to optimize this, what the normally came with the approach. Okay, if we have the users access our server, okay, and if he is accessing first time, go hit the database, okay, retrieve the information, update in the cache. It's a local cache, or you can say local memory for the server, and retrieve it. If the user is going to request for the same resource, first check with the cache. If it is the available, get it from here only. So we can totally avoid this network call. So I hope you have a pretty much fair idea what is the cache purpose. It's just temporary memory. If you guys are already using the browsers, okay, so first time you have observed that website is taking too much time to load, but if you are a regular user, it cached some kind of information related the website. Okay, then by the next time if you are trying to access them, it's quite faster because the local cache. Sometimes if our browser is not responding well or not getting updated data from the server, so we have also have been asked that, hey, just go and control shift delete, remove the history, remove the cache. So that is all the cache. The drawback of the cache is that it might be possible that it's not the updated value. So there are the various algorithm they're based on that with the user and your customer and like your a commitment we have to must be agreed upon. There is some kind of data which could be a stale data, which could be not the latest or the newest, but it's okay. For example, there are the most common data which is being used commonly and least frequently updated. For that particular kind of other things we can do it, but to handle all these kind of scenarios, there are the other kind of approaches are there that will take care in the coming sessions. Okay, now we'll just go and iterate whatever the things I have told you. Caching is a technique to speed up the data lookup. Okay, it's just whatever the data you are just going to look up, this is going to speed up. Instead of the reading the data directly from the source, okay, which could be the database and another remote system. Okay, the data is ready, read directly from the cache on the computer, and that needs the data. Okay. Okay, cache is a storage area that is closer to the entity needing it than the original source. In simpler words, whatever the latest possible, most nearest possible server or entity, that there it has to be placed. So that is accessing the data through the cache is typically faster than from the original source, because there would be a network traffic, okay, and all those things, network traffic call be in the picture. That's why it's a kind of slow, and there are the various other reasons as well. Secondary storage area, so that is not that quite efficient. There could be many multiple reasons to for the slowness of the real memory. Okay. A cache is a typically stored memory area on the disk. In this modern web application, yeah, applications takes place at the three location: browser, web server, and database. So we could have the browser at the browser, servers at the database. These are the three places most commonly where we are using kind of the cache. Browser may cache static files and data. Okay, these are the things that I believe you have already aware about. Just going through a very fast this slide. Okay, there are the we are implementing the cache that you can three. We have a kind of miss how we are going to manage the cache or populating the cache. So first category is the upfront population. Okay, while your application is loads up, you just pull up the data from the backend and it make it available to serve to the users. Okay, so that is the case of the upfront. Okay, second is the lazy population. What does it mean? Lazy population means whenever when just update your cache only once if first time record doesn't exist in the cache, and then just move it to data, just get it from database, update the cache, and then send back the response. Okay, by the next time if the second request came, then just check in the cache, and if it is there already, and just respond it back. Okay. Okay, they are the cache and remote system. Write through means we have to write time-based expiry, active expiry. So based on the time is how long we want to contain some kind of data for the expiry. Okay, so these are the some things. If you just take a pause and go through all this mechanism that is being required. Okay. Okay. So there are some eviction policies. Eviction policy का क्या मतलब है? Means eviction policy is something could not have a cache is mainly the expensive memory. It could not be limitless. Means for example, if I talk about the RAM, we have only 8 to 16 GB of the RAM. Okay, because it's expensive. expensive memory. Okay. So what does it mean? If we have a data of, let's say, 60 gigabyte, and we have a server, and let's say we have a limitation of our cache is only let's say 50 MB. So there miss we cannot exceed this limit. Okay, let's say we have example. So there is some mechanism to do not cross this limit. We have to remove some data. So the mechanism on which priority we are going to remove data from here, that is known as the eviction policy. Means what are the things that we are taking to consider the priority, to make the priority for available cache. Okay. मीन्स इन शॉर्ट इसमें कौन सी प्रायोरिटी है जो हमें सबसे ज्यादा इंपॉर्टेंट कंसीडर करनी पड़ेगी ये इसको निकालने के, दैट्स द मोस्ट इंपॉर्टेंट थिंग, राइट? ओके, so first eviction policy is the time based eviction policy. Means once you have put some data into the cache, okay, you said that this data particular we are allowing him to for only 1 hour. After 1 hour we will remove it. So that's a time based. So time based eviction is similar to time based expiration, which has the covered earlier. In addition to keep the cache in the sync with remote system, the time-based expiration can also be used to cap the cache size down. Okay, either you have to separate the thread running with their common which monitors the cache and keep clear or clean up it done. Okay, attempting to write a new value to the cache. Okay, second is that first in first out, which means the element which comes first in the cache would be removed first. Okay, so first in when you attempt to insert a new value into the cache, you remove the earliest inserted value and mark the space for the newer one. Of course, you do not remove any values because the cache meets the space limit. Okay. First in, last out means it's a kind of queue where the element just keep on inserting 1, 2, 3, 4, and let's say reach the limit, and then it would be removed, and another element will keep on inserting at this particular place. Okay. In the least accessed, these are the very two important eviction policies that I am talking about. Least access, suppose that you have a data of, let's say, 100 records, and number 3 records is not being used quite frequently, so it's not being used. So we can, while adding another data to this particular cache, we can remove it. Okay, least access eviction policy means that the cache value that have been accessed the least number of the time are evicted first. Okay, means जो सबसे कम बार access किया गया होगा उसको निकाल दिया जाएगा. ठीक है. The most of this technique is to avoid having the reread to store the often read values. In order to make the technique work, the cache has to be keep track of the how many times a given values has been accessed. Okay, the least time between access. Okay, least time between the access means between access the least time if two consecutive access for the records, that is the kind of comparison that we are talking about. Okay, least time between the access eviction taken between the access of the value into the account. Okay, when a value is accessed, the cache marks the time between time value was accessed and increased the access count. When the value is accessed next time, the cache increment access count also, and also calculates the average time between all the accesses. Okay, the value that the one accessed a lot accessed not a lot, but in the priority we'll have to drop average time between the access. The sooner or later the average may drop enough and the value will be evicted. So it means less frequently used. If they are not, there is a huge gap between the access, so we can move to kind of. Okay, so this is all about the caching methodology. So this was good. So I'm just moving and let's now it's a Hazelcast basically. So why the Hazelcast is required? Okay, what additional thing that Hazelcast give us? Okay, so first of all, Hazelcast is a library, or is a library which is compatible with the Spring Boot. Okay, that's the one thing. Second, it's basically for the Java libraries. Okay, the major thing is that this kind of right now, whatever I have talked about, we will have talked about single JVM. Okay, if we can store the value, that would be per JVM. Let's say we have stored, we have running the 3 nodes, 1, 2, 3. So as per my current explanation, we have to maintain separate caching mechanism in each node. Let's say this one, and this one. Okay. Now, Hazelcast, how it's going to help us. So what does it mean? First off, let me tell you. Simple means is that if you are going to access, suppose that the record A is trying, you are going to access it, it will go hit over here, and then it's going to the, let's say, database. This node is particularly going to serve it. It's update the cache and return it back. And if you request A again here, okay, it will not go to the it will not go like, let's say, to the server, but it revert it from over here and give the updated value. But the things is changed when, suppose that you are running through some kind of load balancer, okay, and you request another user, or you are requested for the same resource, and instead of server 1, it's redirected to server 2. Okay, here it doesn't find the cache. It will again go to a server, and it will get the data from there, and again it's going to update the cache and send it back to you. So means the point what I'm trying to communicate, even for the front-end user, this is was one single application. Okay, even if they are hitting different servers, they still, there is an additional call has been made per server. Okay, which is an additional overhead. Okay, so Hazelcast come up with this solution. Okay, Hazelcast is a distributed in-memory caching system. So basically is a distributed in-memory caching system. Okay, so if we are running a node over here, 3 nodes, so how it is going to handle? Okay, there are the 3 different topologies that we will talk about later in this section. But what it does, it creates internal kind of cache, and that are in sync in all the states. Okay, like this way. So if they are in sync, if someone has requested, a resource has requested, first time it goes to the database and pull up the record and send it back, update the cache and send it back. If it again access it, because now as a next step, your through the sync process, it's the cache has been updated, right? Also, this node also has been updated. So there is a there might be some slight nanosecond of delay, but if the another user are trying to access this one, it will not hit the this channel. Okay, it will figure it out. Hey, this is already available, and just send back to response. So it's worked perfectly with the different nodes in the distributed environment. So this is the way Hazelcast is going to solve the issue. Okay, so there are the different topologies. We will see in this lecture a couple of we'll see in this lecture how it is being solved in the through a Spring Boot application. Okay, and we'll see the demo, and also I will share all my useful link in the below in the description. From there you can find it out, all those things. Okay, so let's move back to the my slide. Okay, now come back to the definition. Hazelcast is a distributed computation storage platform for consisting low latency querying, aggregation, and stateful computation against event stream and traditional data sources. Okay, it allows you to quickly build a resource efficient real-time application. You can deploy it at any scale, from the small edge device to large cluster of the instances. A cluster of the a cluster of the Hazelcast node share both the data storage and the computation load, which can be dynamically scale up or down. So that is the means you can spin up new instances, new nodes of the Hazelcast. How to means new nodes of you can scale up depending upon the load of our application. Okay, so there is basically the three types of the implementation that we are going to talk about in terms of the topology, how the Hazelcast is being implemented over here. Okay, so first is the embedded caching technology. So that's we have given the picture. We have the Spring Boot application, and within the that particular node, we have a Hazelcast. Okay, and each of the Spring Boot application with that we have the Hazelcast member. When a new cache entry is written in the cache, the Hazelcast take care of the distributing in other members. So if anyone is updated, is the cascading happens, okay, in the similar way, but they are all the same. The drawback of it, suppose that you have 100 nodes or thousands nodes. All the thousands node would be having these kind of scenarios. Okay, and the communication between the nodes, because it's a syncing process, so it would be again a pain, because all the hundreds node, if any one of the nodes is getting updated value, that has to be reconcile or sync between among the other nodes as well, right? क्योंकि सभी क्या होगा कि सभी नोडों को फिर धीरे धीरे सारे को अपडेट करना पड़ेगा, तो इसमें बहुत ज्यादा कॉल हो जाएगी, नेटवर्क कॉल्स बहुत ज्यादा हिट कर जाएगी, और इसकी वजह से प्रॉब्लम इट्स इज अ काइंड ऑफ प्रॉब्लम इफ वी हैव मेनी नंबर ऑफ द नोड्स. Okay. Okay, so Hazelcast provides the several mechanisms to discover if we want to configure any discovery mechanism. The default one is used. I find another one, the same network using the multicast. Multicast, what is the multicast? That you really need not to tell the Spring Boot or any application. It will it's just try to find itself the association, and it will figure it out automatically where I have to connect. Okay, let me show the better definition over here. Okay, if we talk about the discovering mechanism, discovering member by the multicast. Okay, so with the multicast auto discovery mechanism, the Hazelcast allows the cluster member to find each other using the multicast communication. Okay, the cluster communication do not need to know the concrete address of the other members. So means it's not required to know the address of other members, as they just multicast to all other members for the listening whether multicast possible or allowed depend upon your environment. Okay, so if your environment allows the multicast, it will automatically automatically figure it out of whom I have to connect. It's really very easy to set up. We'll see in the practical example. There is a Otherwise you have to tell where your cluster, where your nodes, Hazelcast nodes are running. Okay. uh, Imagine we have a system required as 100 of instances, our application in the cluster topology. It means that we have 100 cluster member, even though we don't need them. This is the bigger number of the cache. We would consume a lot of memory. Okay, that's we have already talked about. Also, the replication and synchronization would be pretty expensive, because we have a lot of network call. When an entry is added, updated in the cache, this entry would be synchronized with other members of the cluster. Okay, uh, which causes a lot of communication. Also, we have to note that Hazelcast is a Java library. That means the member can be embedded in the Java application only. You cannot do it in any other language. So, or if you talk about the embedded, so embedded in the Java application only. No other applications are allowed. Now we another topology. Suppose that not to overcome. Suppose that we have 100 nodes are running. Now we don't want to do this unnecessary memory, because everybody is sharing the same information. What's the new use of it? Okay, so in that case, we can create. We can create um, another cache cluster. Let's say we can create a 1, 2, 3, 4 cluster nodes, and then our Spring Boot application through the Hazelcast client can connect to the cluster, and from there we can get the information. So it's another way. The advantage is that we could reduce the number of the replica memories, and depending upon our availability, we can spin up as we want. Okay, so these are the things are availability, and we can minimize the cost of that. Okay. uh, okay, so there is another concept of the near cache, which is, you can think of basically the cache of the cache. Okay. When we use the client server topology, we are producing the network traffic. Okay, when we are doing network traffic, because even the client server, we have a lot of networks that is being traveled. Okay, not it's depend on the two cases. When it happening, basically two cases. When the client reads data from the cache member. Okay, whenever reading is happen. Okay, so unnecessary the network calls is happening. When cache members start the communication to the other cache member for the synchronization, because if we have a 2 or more than servers, we have a kind of synchronization process. So that's additional cost. So these are the two areas where data syncing process is happening. Okay. Now move to the solution. It's a kind of it's a near cache. The concept is that basically the near cache. What does it mean? Which means that let it be the client server model. Okay. We will create a kind of near cache of the means in the Spring Boot application itself, and you can just think of cache of caches. Okay, definitely here would be some kind of real system that where we are going to interact with, but at the first step, Spring Boot try to figure it out, find out that is my data is available in my local storage area. If it is not that, then go to the real Hazelcast cache clusters. And if that information is, if you got it, retrieve it from there, update the near cache, and serve the client. Okay, so it's you just can think of the cache of the cache, and we reduce the network traffic. Every client clears the near cache when an application requests data from the cache. It first looks at the data in the near cache. If doesn't find the data, we call it the cache miss. Okay, and then we can hit the real data. Okay, So that's pretty much all about in terms of in terms of theory. Now let's move to into jump into the practical sessions. Okay, so to show you the practical, I have created one of the it's a basically I would be I'm also going through this Hazelcast example, and the same example is being I have used for the demonstration. This would be available as the description box. You can get it from there. Okay, so what are the steps that you have to take it? First of all, if you go to the dependencies, we have Spring Boot starter parent, and then we have a Spring Boot caching, the guided cache, and there to manage it, we have a com.hazelcast, hazelcast.all. Okay, and how to do it? Let's close all of the tabs. If we start from the application XML, first thing what we have to do, if we go to imports, enable caching. That's a notation that we have to use it to enable the caching in your project. Okay. Okay. Now we have to go, let's say controller. Let's take, this is the controller. And if we am going to trying to get any data and I just want to cache it for the book service. Okay. Now go to the book service. Here is the cacheable, whatever the resource that you are want to do the caching mechanism. Or by the way, here is a no specific. It's means all the implementation of your cache is hidden by the Spring. Spring is very smart enough. You really don't need to write any specific annotations to use it. So if we have created the book annotations, if we are trying to get the same data, and here the programmer did the explicitly delay of the 3 seconds. First time, let's make it at the 5 seconds to reproduce it. First time it will give you the delay of the 5 second, and then you can go it. Apart from this, what we have to do, we have to enable the multi-class. Okay, the moment you have did it, the multi-class, your program will came to know that, hey, I have to be it has to be the Hazelcast that we are going to do it. And that's why if you talk about the resources, is the nomenclature is that hazelcast.yml. Okay, so if you want to go in detail, just read this document, but I'll be going through kind of demonstration. Okay, let's start with kind of at 81, and then I'll start at 82. So first remove these two things and let it be start and observe the logs, how the logs are being populated and what the things are being mentioned over here. Tomcat has started at 8081. Okay. So okay. So you can see it has registered one member in the Hazelcast. So basically it's written that a Hazelcast lifecycle, it's running, is started. Okay. Okay. With the Tomcat embedded server. Now I'm just moving to another configuration. Let's say this was 8080, this was 8081. Now I have to move to 8082, and then I have to another start one. Okay, so this time you can see the second instance is also being registered with the Hazelcast. Okay, here we can see the size is 2, version is 2. If we can instantiate more than this, we'll get it. Now let's check our application. Okay, so let's hit by 8081 with the same record, and it would be probably going to be take 5 seconds to respond. And also we can see in the logs that the real method has been executed or not. Okay. 1, 2, 3, 4, 5. Yep, we have responded, got some data, and if you go over here, getting from Devi. So I have just explicitly okay. Okay, if you do hit it again, there would be no such statement. We are going to get it any number of time. If you are going to do it, nothing is going to do it, but you are having no delay. Okay. Now move to another one. If I just go and change the port, let me change the port of it, 82. Okay. And let me send it the request here. See, we have got the response, but it still does not hit the database. There might be some delay to know whether the peer version, the data is exist or not that way, but it's really doesn't hit the database. It doesn't invoke the functions. So I hope that's pretty much clear, the Hazelcast, how it works in the distributed environment. And I hope you have liked this video. So I hope please enjoy. Please let me know if any feedback, comments. Thank you. Thanks for watching. Bye-bye. Take care.